So here's your project for tomorrow. This is going to be an in-class assignment, right? It's similar to the one we did before. It was just a square. Now it's an octagon, stop sign, and you already know like the equations to graph the sides. The y equals 5 is the top. It's horizontal, 0 slope, and we know x equals 5 is the side, right here. Okay. And how do you graph, or how do you get the corners, or these diagonals? Right? How do we find the equation of the line there? So we know that we can find the the slope from here to here, right? So what would that be? What would the slope be from here to here? Maybe this view will help better. So we go down 3, right? 3, right? But so that'd be the equation y equals, well, down 3, right 3. What does that equal?
1.
Yeah, close.
-1.
-1 over 1 x. But what is the y-intercept?
0.
Right, I need it to be right here on this edge. It's way down here, so maybe 6, not quite. Maybe 8, that kind of overshoots it. And then 7. There you go. That gets the side, and then we can use the domain or range and say it's from x, we're looking at the x-axis, so it's going to be from 2 to 5 here, and then you can put in that domain. There you go, and then you get the corner. So that's one way of doing this, and you'll finish the whole thing tomorrow. Okay? You'll finish this entire thing tomorrow as your in-class assignment. Do it at the end of the period. But what if you need to find this equation and like there's a bunch of decimals and things like that? We can't just go off of like counting squares. So on your homework today, if you look at it, it's asking you to find the equation of the line, but without using a graph like we just did. Because at some point we're not going to have these easy graphs that are nice whole numbers. They're going to be decimals, they're going to be fractions, and we won't be able to just say, oh, it's +6, oh no, it's +8, oh no, it's +7. That's the perfect one. I mean, what if it was 7.38? Like, how would we figure out that exact number? And if we're dealing with money, and this is some real life graph, yeah, you actually have to do perfectly. You can't mess around with money and say, well, 6 is pretty close to $6.38. Because when you start doing that for maybe thousands of people or selling thousands of products, it turns into a big discrepancy. So we want to have a way of getting these equations, right, just by knowing, well, I want it to go through here, 2, 5, and I want it to go through here, 5, 2. How do I find the equation of the line that goes through those 2 points, but without doing this trial and error process? So that's what your homework is going to be all about. Is given, mostly starting down here, given 2 points, what's the equation of that line that goes through that 2 points, but without using a graph like we just did? So you use this right here for your project tomorrow. Okay, you'll have to be doing this correctly. But first, to do a little introduction and a little practice, a little review of slope, and then we'll get into how to solve those, how to get those equations. Okay. That's what you'll be doing there. So recall down here how to find slope. We had an equation or a formula that looked like this. there we go. Look like this. M equals, M stands for slope, and we had something like this. Y2 minus Y1, the rise, and X2 minus X1, the run on the bottom. And I mentioned to you the most common mistake on here is usually negatives, so it's a good idea just at the very beginning when you use this formula to just put in some parentheses being subtracted on the top and bottom. Like that. And then go ahead and plug in the numbers. Just make sure you plug in the y's on top, the x's on bottom. Alright, so we have the y's on top, so it'll be 4 and negative 4. And the x's on the bottom, which would be 5 and negative 17. So that's the only part you really have to be careful on. And then, of course, if there's double negatives. And, of course, some people will say, but this shouldn't y2 be here? And I picked this one. And we talked about that before that, well, it doesn't matter because there's only one line that connects these 2 points. So the slope from here to here is the same as slope from here to here. It doesn't matter which one I call y1 or y2. As long as you don't put the x's on the top and the y's on the bottom, you're fine. Okay. So if you want to do it both ways, then you'll find out they'll come out to the same answer. Right. So we have, 8 over 22. And of course, always, so that'd be up 4, right 11. For that slope for number 5. Now, what I'm going to do right now, I'm going to show you another form for what if you have a slope and a point and you want to plug it in, get the equation. I'm basically going to take this right here, this slope formula, and multiply both sides by this. What it's going to do is going to move the x's next to the m. Cancel on the left and move to the right. You're going to get a format that looks something like this. So, put this down. This is the primary formula you're going to use. It's just like the slope formula. I'm just taking the x's that were down here on the bottom, and if I multiply that on both sides, it's going to move them to this side. And as you know, is the slope still. And then you're also going to plug in an x and a y. An x right here and a y right here. And that will give you your equation of the y. And number 1 is an example of what if you're given a slope of 6/5, 6/5, and the x and y of 5, 4. Actually, of negative 5 and negative 4. And they're plugged into the formula. This is what it would look like. Notice how, since the equation has a negative, the fact that this is positive means x is negative and so on. And then you can solve this for slope-intercept form just by doing sugar property and doing a little bit of adding or subtracting on both sides. So 6/5 times x is just 6/5. 6/5 times 5 is 6. And I want to get y equals. That's what slope-intercept form is. So you want to get y equals mx plus b. So subtract 4 on both sides. And now you have y equals 6/5 of 6/5x plus 2. So that's the short part. This is like the last part of every one of your problems towards the bottom and the back side. This is the second part of it. You're first going to plug it in, and then you have to convert it to slope-intercept form. So we start here. This was called point-slope form. And when it's written like this, and at the end we're trying to end up at slope-intercept form. So you got to know the difference between these. That's slope-intercept form. And you got to read the directions. It says write a slope-intercept form. We have to know what we need to write it as y equals mx plus b. We like the point slope because if we don't know what the y-intercept is, we can just use any point that we know is on the line. But then we can convert it into slope-intercept form, something we're able to graph it. So let's just practice one more time, plugging it in. This time I gave you the point and the slope. So it'd be good practice just to write out the point slope form a few times, just write it out without anything plugged in until we really get the hang of it, and we'll do this. If you get confused, just remember it's basically the slope formula. Just the x's that were on the bottom below the y's are now next to the slope. And we only have one point, so we drop the y2 and the x2, and we just keep one point in place. Alright, so we have y minus. I'm just going to write it all out. Plug in the parts that. Okay. So slope is -9 fifths, right? So I'm plugging in m, -9 fifths with no slope there. And x and y. Which one goes in carefully? Which one goes here first? Yeah, that's the -4. And then of course over here is the 5. Now you will get double negatives. Anytime there's a negative in the point, since the formula also has minus signs, anytime either of your coordinates are negative, they'll turn into a double negative, which will be a positive. So you get y positive. Anytime a point's negative or a coordinate's negative, you'll have these double negatives. So again, just like we just did right above, distribute and solve. We got -9 fifths x. What's -9 fifths x times -5? Plus 9, right? So the 5s are basically canceling out. There's one on top, one on the bottom, and then you have negative times a negative, so you're left with +9. So a little bit of fraction work, but something we can handle. And then go ahead and, just like we did before, subtract. Or add whatever numbers on the left side. Y equals -9 fifths x plus 5. So we found out the equation of the line just by knowing a point and the slope of it. And I didn't have to go here and use a graph to figure it out. That's the important part. Now we can do all this without actually seeing it. It'll work the same way. Okay. So that's kind of like the warm-up. After this, this is what you're really going to be using for your project. Coming down here. They're just giving you 2 points, kind of like on the stop sign. If you know you want a line to go through these 2 points, how do you find the equation of that line, but without doing some trial and error? Okay. So we're still going to use the point slope formula. Right? We still have this, but there's something missing. What do we not have? What did we have before that we don't have now? What's missing? If I told you to use this formula right now, what would you not be able to plug in? The slope. We don't have the slope. We could plug in 1 and -5 for x and y, but I do not know what the slope is. Luckily, you know how to find slope, right? That's what we just did right here. You know how to calculate slope if you're given 2 points. So there's really two parts to this question. We have to find the slope first, and then plug it into the point slope formula. So y is on top, x is on the bottom. Simplify. So I know now that my slope is -3. So I can now plug it in here, slope of -3. And you get to pick which point you want to use. You can use either one, you'll get the same equation. So let's say if I wanted to pick here, let that be x, let that be y. So I'll have y minus -5, right? So we get the minus from the equation, but we have the negative from the point. So we got two negatives there. And we have -1 over here. Don't forget the equal sign. And just like we did before, like I mentioned, this is the last part of every problem. It's just putting it in slope-intercept form. So we could graph it if we needed to. Okay. Do you guys agree with this? Yeah, watch your negatives. Definitely watch your negatives, though. So negative times a negative, positive. My experience with these problems is that the algebra is pretty straightforward and easy, and the mistakes are with arithmetic, like just negative times a negative is a positive, things like that. The formula, you guys know formulas. You just plug numbers in and get the answer. But if you do the mechanics wrong with all the negatives and stuff like that, yeah, it's not algebra. It's just being careful with your arithmetic. So we have -3x minus 2. There you go. Let's have you guys go through and do number 8 as a practice. Use number 7 right beside it as an example. And, oh, actually, yeah, this one's a little different. Yeah, the slope comes, yeah, let's go through here and actually do this together. So here, if you went through and you found the slope, really quick, you'd find out that something's different about it. Right. Because the y's are both 1. Right? Both y values are 1. And when you do 1 minus 1, you'll just get 0. And 0 over anything is 0, so it doesn't even matter what the bottom number is. You just get a slope of 0. Which will make, you can still do all the same steps, so it'll make things a lot easier, multiplying by 0 and whatnot. Okay? So plug it in and see what we got. Go ahead and plug those in and see what you get for your equation. Okay. So you probably realize pretty quick that plug in x and y, and your slope, yeah, looks a little weird. Zeros. So the whole right-hand side, 0 times anything is 0. So I know this is y minus 1 equals 0. And add 1 to both sides. Y equals 1. And you might have noticed, or remember this from last week, that, yeah, if the two coordinates are the same, that's when you have kind of what we had up here. If the y's are the same, yeah, you know it's a horizontal line. That's a slope of 0. The range never changes. Right? Never changes. Just stays the same. And that's why we have just y equals 5. So if the y coordinate ever repeats, you know it's just going to be y equals that. The same thing applies for here. If you have two x coordinates that are the same, like here all the x coordinates are 5, no matter where you go on the line, the equation of that was x equals 5. Right? So if you can spot that ahead of time, you can save yourself a lot of extra work. Right? Not a bad observation. So yeah, repeated coordinates that are the same, it'll just be, yeah, if both y's are 1, the equation is y equal 1. So, what would you say on number 9? What's the equation of number 9? What do you notice about the x-coordinates? They're both 2. So, what's the equation of the line? Just x equals 2. That's it. Because we already know, yeah, that's, if an x is repeating, that means it's a vertical line. Vertical lines have x equals as the beginning of their equation. You don't really need to. You can, if you tried to go through and find the slope, you'd find out that the top would be, what, 4 minus 3, and the bottom would be 2 minus 2, which is 0, and in mathematics you can't divide by 0, you just get an undefined or answer. And that's where the whole point slope won't work. Nothing will work because you have no slope. If you don't have a slope, you can't use the point slope form. And you'll start noticing that, yeah, I can't put this in slope intercept form because there's no y equals. It's only x. Alright, so let's practice, let's see, with a few more. Yeah, like 15. Be a good one. And go ahead and try to do the whole, all the way through the whole thing. This isn't going to be a vertical or horizontal line, so let's try to do one from beginning to end all the way through. Remember, start off by finding the slope of the 2 points. Alright. And then getting that answer down at the bottom, getting that answer, and then plugging that into the slope, point slope form. So there's a lot of little things going on. That's why we are writing all the formulas down to make sure we got it. After a while, you won't need to write the formula down. Just write it down with the numbers in right away. But at first, definitely need a lot of practice on here. Okay, so go down. Okay. So let's go through this. Again, the x's, no, the y's on top. X is on the bottom. So we have 3 over 3, which is just 1. Okay. Got 1. So if you didn't get 1, well, if you didn't get 3 over 3, that just has to do with your pluses and minuses and negatives. That's arithmetic. Just use a calculator to double check if you're missing negatives at this point. Okay. If you use 3 over 3, just remember you reduce it. It's easier to plug in 1 than it is 3 over 3. Okay, so now we can plug in m, we can plug in 1. You can pick either one of these to plug in x and y. You can't mix and match, though. You have to pick one of them, x and y. So which and it doesn't matter, so I'll pick this one. Doesn't matter if you pick the other one, you'll get the same answer. So my y is -2, and my x is 4. Alright, so let's plug these in. So we got y equals there we go. Okay. So looking at this, what's the mistake? What is the mistake on this? Find it?
Yeah,
Yes. So don't forget that there's a minus in the formula, right? As well as a minus on the coordinate. So if you don't see those double negatives, like I said, one little mistake on the negatives will mess things up. Another way of thinking about it is that anytime there's a minus here, it's going to be a plus in the formula. Right? So if you ever see like a negative, like you had one here as well, so you had a, if you use this point, you had y plus 5. Okay? All right. And then we can finish it up by subtracting 2 on both sides. All right. Another way you can, another thing you can do just to make sure, because you know, things can go wrong if you're not careful, which even if you are careful, it can go wrong. But a way of checking your work for tonight. Go back to Desmos. Alright. Move that page. And plug in the 2 points and plug in the equation and make sure the line that you got actually goes through the 2 points. So I mentioned this before that there's an app for Desmos. It can become quite handy. So go ahead and plug in. Here's what you do to check. Plug in the 2 points that you got. Let's see here. 1, -5, 4, -2. Okay. 1, -5, and 4, -2. Right? So here's what you're doing graphically. You are trying to find the line that goes to those 2 points, and then type in your answer. What do we get? Down here, we got y equals x minus 6. And if it goes through the 2 points, that means you got the right equation. If you made an error somewhere and you got x minus 4 and you saw the line doesn't go through the 2 points, you know there's a mistake somewhere. So that's a way of checking it using Desmos throughout the homework. So like I said before, you have to have a reasonable amount of accuracy on your homework, and it has to be mostly done by the time you get to class, minus maybe a few that you couldn't figure out, but you can get help right at the beginning of class. So this is one way of making sure that happens. And if you don't have it at home, you can always go in the library. It's open until 5, and you can use computers there. So there are options. All right, so I think that'll leave you with enough. There are some other shortcuts I did not mention, so you might notice them, or maybe not. I'll leave it up to you. If you find some other shortcuts and you think, wait a minute, is this always going to happen like this? Check around with a few other problems, and maybe you'll find some of your own, and you'll find faster ways of doing these just by observing a few patterns. Okay, so go ahead and maybe try one more on your own before the bell rings. You got about 4 minutes, so you can maybe get one more done.